So you may have noticed a lot of the examples that I've been showing already have conditionals in them. So this example isn't really much of a departure from some of the examples that I've shown. However, wanted to show a couple different things to note about using conditionals. So conditionals are essentially these if, then, else statements. And often you're just a simple if then statement will work for your what you need to do, but it's important to note that you could nest these. So here in this example we have an if that checks if the user input is a number. Again, this is going back to data validation. And if it's not a number, then show alert and tell the user to please enter a number. If this is a number, then it's okay, we could process that data and we will then do a check, and you'll see that this if then else statement here is actually nested within this if else statement. So you could nest them, and that's fairly common. I would recommend not to nest them more than 2 or 3 deep, because once you start to get deeply nested if statements, it becomes very difficult to read the code and kind of pick it apart. So it's best to keep these nests shallow. And if you find yourself in a position where you're having to nest deeply, then you probably need to rethink your code. So a couple other things to note about this example. Well, before I do that, I should mention that ifs, the conditionals are in the control section. So if we pull out if then here, you'll see that there's also this little gear icon here, and if you click on that, that's basically how you add else if statements. So I'm going to drag that else there, and it'll click into place, and you can add as many of these as you need. I should say if there's only one else, we'll say else if here, and this could go on for however long you need to check any type of or to evaluate any type of data here. So that's basically how you build those. Now this program here, what it does is you enter a number and it evaluates whether or not a random number generated from between 1 and 100 is greater than or less than. So I'll choose 5, evaluate. 5 is less than 56. Okay. If I put 89, evaluate. 89 is greater than 17. So it's a contrived example. However, it demonstrates a couple of important concepts, namely the nested if, also data validation here. And this is a good way to kind of build out your validation. Is it put in the first if, check if you're getting the data you need, and then you could, any other logic that you need to execute could then just be nested into this else statement. The other thing that's going on here is we are using this math method called random integer. So this is a very helpful function to call, especially when you're building out games, because it's often that you need to generate random integers. So that's available in the math section here. And then finally, I wanted to point out this thing that says initialize local variable. So I haven't mentioned this yet, but variables are really essential to programming languages, and variables like in algebra are basically a name for a piece of data that can change value over time. So an example of a variable name would be first name, to hold a person's first name, or last name, to hold a person's last name. So any data that you need to store so that you could then reference later in the program, you're going to declare a variable. And so there's this special section here called variables, where you initialize variables. You could get them or set them. Get them just means you're going to read them into the program. Set them means you're going to change their value from what it was prior. But the one important distinction to note here is you have this thing called global variable here, and then you have this variable here that says initialize local variable. And there's a section in the Technovation curriculum that describes the difference between these two. Global and local refers to what programmers call scope. So there's global scope and then there's local scope. Global scope, it basically means that variable, if you assign a variable to global scope, it's available to be read anywhere within the program. So if I have a global variable here, I could use it anywhere within these blocks. Now, if you're using a local variable, like here, random number, this local variable can only be used within this this block. So it says initialize local variable random number, and then it says in. And so random number, if I had another block out here that wasn't nested within this initialize local, I could not access random number. So that's the main difference, and it's best to try to use local numbers as much as possible, or local variables as much as possible, so that you don't cause any variable collisions. But we won't get into that. Just note that local variables are only accessible within blocks that are nested within it, and then globals are just available everywhere within the program. Okay, so that's a pretty simple, straightforward program. We'll exit out of here and talk about lists and loops. So lists and loops are another important concept in programming, because basically, like as I mentioned, you're manipulating data, and a good way to store data is in a list, because you could add to the list, you could remove from a list. So let's take a look at what's going on here in the user interface. Basically, I have a text input and then this add item button. And so what I'm doing is I want to type in some text here, click add item, and I want it to add it to this list view. So this here, you'll see, is this list view. And that's what this is a pretty simple example of like a to-do app. And in the Technovation curriculum, that is one of the assignments, is to build a basic to-do app. So let's zoom out here. Let's see what's happening. So let's take a look at this add item. So when I click the add item button, it says add items to list, and it's getting global list items. So let's see if we could find that. So here again, a global variable called list items, and we initialize it to create an empty list. So that's what we're using to store our list items. Once you add the item, it says take whatever item you typed in the text box, set the text box to empty, because that will clear the text box, and then set list view elements to get global lists, get global list items. So I will demo that here. So this is a to-do list. So today I need to walk the dog. We'll add the item here. You see it adds it to the screen. I need to buy groceries. Add the item. And then I need to grade papers. Add item. Okay. So here you'll see that it just adds it to this list on the screen. Just to kind of demo a few different operations that are common. Often when you have a list, you'll want to do what's called a loop through it. So here you say you have this when loop list click. Zoom in here so you can see it. If the list is empty, then it shows notice your list is empty. So I'll show that in a second. But if I click on this loop through list, what it does is it will go through all of these in the list and output it. And so that's what this for each item in list, get the list of items and then show an alert. And then also I'm performing some operation here. So what I'm doing is I'm getting the length of the item. So that number that you see here is basically the number of characters that are in there. So buy groceries and then grade papers. So that's this for each loop is how you would go down a list of items and perform some operation. In this case, counting the number of characters in that string and outputting it to the screen. Another thing you would do is you might want to add an item at a certain point in the list. So here I will say, let's see, take out trash, and then I'm going to add a comma here to add the position I want it to. So let's say I want to put it after walk the dog. I'll put 2 and add item. And let's see, that did not work. Why did that not work? Let's try this again. Trash. Okay, it appears I have a bug in my code. Oh wait, silly me. So I'm pressing add item, that's why that happened. So trash, comma 2, done. What I need to do is press this insert at index. So that 2 is the index that I want to insert it at. So if I press insert at index, alright. It's supposed to put it here. That's right. Now I remember. Okay, so if I click OK, you'll see that it added it right after walk the dog. Okay, so this insert after index says, click show text message, add new item, title new item. Okay. So it calls this text notifier, and then it performs this operation here. So again, it new item with index, create item list. It appends to this list. So it's taking the new item that you added. It's splitting it into two lists, so it's taking the item like trash, and then it's taking the number and 2 and it's splitting it. Then it says insert this item into the global list. So select list item list, get item with index, index 2, and then select list item with index 1. So in the example that I just entered, trash, 2, it says it gets the index, which is 2, and then it gets the item, which is trash, and then it inserts it into the global list item, and then sets the list view to list item. So it's a little hard to kind of read if you're not used to using lists, but this is essentially what we're doing. Is we're saying, okay, find take the input and then insert it into the index that you want it to be positioned at. So so play around with that, and once you get the hang of it, it starts to make a lot more sense about what indexes are. Indexes are essentially just the position within a list. And then the other thing that you do often with lists is you delete things from a list. So let me zoom out and see. So we have this here. List view after picking. So this is an event handler after picking that says after you click on one of the items in the list, go ahead and remove it. So it says remove list item from global list item where it's the index, right? So if I click on buy groceries, it'll delete it from the list. If I click on grade papers, it'll delete it from the list. So that is the general idea of lists and loops. So we'll go back, and then we will then finish up on the concept of functions. And so it's common. So for functions, it's in App Inventor, functions are actually referred to as procedures. So in almost every other programming language, it's known as functions. Some of them call it procedures, but here functions are referred to as procedures. Now, functions are a very powerful way to prevent rewriting code over and over again, basically repeating yourself. There's this concept in programming called DRY, which stands DRY, means do not repeat yourself. So let's take a look at this functions here page. So here we have 2 text boxes and 2 buttons, and again, this is a contrived example, but what this is supposed to demonstrate is you have 2 locations within the interface that you need to perform some type of operation, and in this case, whether or not a number is prime. And so the one way to do this, and I'll demonstrate the not so dry way of doing this, is you have here button 1 and button 2. and basically they are running the exact same code. This is an identical copy of this. So why is this bad? Well, it's bad for maintenance reasons, because if you need to change the operation of something, if you have some type of business rule that requires you to change the way the program works, then if you change it here, you're going to have to remember, hopefully, to change it here. And so what would be better is if you had this operation isolated in an area that you could then reuse it in a number of different areas. So even though, you know, this works, right? So I could put in, oh, excuse me. All right, I could put in the number here in prime. 2 is prime, okay? Well, that works. Let's see, 7. Is 7 prime? Yes, 7 is prime. 8, no, 8 is not prime. Same thing, so that works here as well, obviously, but say I had a bug in this, I'd have to, again, remember to change it elsewhere. So a much better way to do this is to create a procedure. And zoom in here. This procedure is called isPrime. So it says isPrime, and it will return either true or false. So we will set the initial state to true. We will always say a number is prime unless we find a factor besides itself and 1. So we will run this. We will go through every number from 1 to the number itself, and then if if true equals true, then we will run this and try to find the prime. So get number, if this does not equal number and, yeah, okay, so for example, if it's 3, if this iteration isn't number 3 and it's also not number 1, then we'll run this, and you try to find the remainder of the number divided by whatever number we're iterating on. And if it equals 0, then we know, oh, okay, well, we have a factor of that number. So if you enter 4, eventually it will get to 2 and see that 2 is a factor of 4, and then it will set this to false. A prime would never get to this this part of the code. So we've basically pulled out the operations you need to determine if a number is prime into this function isPrime. Now we created the function, now we'll have to call it. So let's I have this already set up here, so let's actually change this. Let's get this out of here. And we're going to replace all of that code with this. I'm going to get this out of here. Duplicate that. Now you'll say, oh, well, here you're still duplicating code. Well, yes, I mean, there's inevitably you're going to have some duplication in a situation like this, but this is much more manageable than this long nesting, this long block that you're copying all over the place. So when anytime the general rule is anytime you find yourself repeating blocks of code more than 2 or 3 times you should definitely pull that logic out into a function so that you could then reuse that, so that you are not repeating yourself. It makes the code much more maintainable. Other than that, that is essentially the foundation of programming. Data types, manipulating data using booleans, conditionals, if-else statements, looping through lists, and then finally not repeating yourself with functions. So with that said, that concludes this webinar on programming fundamentals. The next webinar we will actually build out a more fully fleshed out, much more useful app using these concepts that we went through today, and we'll take all of these concepts and put them together to build out a much more kind of useful app. Other than that, thank you for watching.